Level measurement using pressure. Pressure is measured in pascals. If a container is filled with liquid, the pressure at the bottom of the container is dependent upon three factors. The density of the liquid measured in kilograms per cubic meter. The symbol for density is the Greek letter rho. The higher the density, the greater the pressure. Gravity applies a downward force to the liquid. The effect of gravity can be measured as an acceleration and can be approximated to be 9.81 meters per second squared. The height of the liquid is also a factor. The higher the liquid, the greater the downward force at the bottom of the container. Height is measured in meters. If these three factors are multiplied together, then the pressure can be calculated. If the pressure is measured, the density of the liquid is known, and the effect of gravity is applied, then the level of the liquid in the container can be determined. For example, a tank is filled with water and the pressure transmitter at the bottom of the tank reads 10 kPa. How high is the water? The density of the water is 1,000 kilograms per cubic meter. The height, in meters, is the pressure in pascals divided by density multiplied by gravity. The height of the water is 1.02 meters. Most transmitters have the option to change the units from kPa to millimeters of water, or meters of water. A transmitter could be configured to have a lower range value of 0 millimeters of water and an upper range value of 1,000 millimeters of water. Millimeters of water becomes a unit of pressure measurement. The pressure transmitter can be used to measure level in the tank. If the same tank was filled with liquid with a specific gravity of 1.2, if the height was 1.02 meters, what would the pressure at the bottom of the tank be? Note, specific gravity is not the same as gravity. The density of the material is the specific gravity multiplied by the density of water. So the density is 1,200 kilograms per cubic meter. Multiply the density by the gravity and multiply by height. The pressure is 1,200 times 9.81 times 1.02 pascals. The result is 12,000 pascals or 12 kilopascals. To give you an accurate level measurement, the pressure reading needs to be divided by density, elevated and suppressed 0. Sometimes the pressure transmitter isn't mounted at the bottom of the tank. It can be connected via a capillary tube. The effect of the capillary tube must be taken into account when measuring the pressure. In the suppressed 0 example, the transmitter is mounted below the tank and that height needs to be added to the reading. The tank is filled with water and the maximum level in this tank is 5 meters and the pressure transmitter is mounted 2 meters below the bottom of the tank. What are the upper and lower range values that the transmitter must be set to? When the tank is full, height is 5 meters plus 2 meters, so the upper range value is 7,000 millimeters of water. When the tank is empty, the lower range value is the height of the capillary and is 2,000 millimeters of water. With the elevated 0 example, the transmitter is mounted above the 0 and that value must be subtracted from the reading. The tank is filled with water and the maximum level in this tank is 5 meters and the pressure transmitter is mounted 0.5 meters above the bottom of the tank. What are the upper and lower range values that the transmitter will be set to? When the tank is full, the height is 5 meters minus 0.5 meters, so the upper range value is 4,500 millimeters of water. When the tank is empty, the lower range value is the height of the capillary, which creates a negative pressure at the transmitter, and the result is negative 500 millimeters of water. The span of measurement in both cases is 5,000 millimeters of water. A sealing pot is a device that can be filled between a transmitter and the process. It allows the pressure to be transferred to the transmitter, but is made of a material that is less affected by the process, so protects the transmitter. The capillary tube can be filled with a substance that may not be water, and so its density will need to be taken into account. This example shows a tank filled with salt water and has a specific gravity of 1.2. The capillary lines are filled with a fluid with a specific gravity of 2. With the suppressed 0 example, the transmitter is 2 meters below the tank. A full tank will have a pressure of 5 meters multiplied by a specific gravity of 1.2. plus the capillary of 2 meters multiplied by a specific gravity of 2. 6,000 plus 4,000 millimeters of water gives us an upper range value of 10,000 millimeters of water. An empty tank will have just the capillary tube, so the lower range value is 4,000 millimeters of water. The range of measurement is 4,000 millimeters of water to 10,000 millimeters of water. With an elevated zero example, the transmitter is 0.5 meters above the bottom of the tank. The negative pressure on the capillary tube is 0.5 multiplied by a specific gravity of 2. This gives 1,000 millimeters of water. The lower range value is negative 1,000 millimeters of water. The upper range value is 6,000 millimeters minus 1,000 millimeters, resulting in 5,000 millimeters of water. The range of measurement is negative 1,000 millimeters of water to 5,000 millimeters of water. Pressure vessels. When measuring level with a pressure transmitter in a sealed tank, there is an added problem that the top of the tank may be under a different pressure than atmospheric pressure. The pressure at the bottom of the tank will be the pressure resulting from the height of the fluid plus the pressure at the top. The first solution is to use either 2 transmitters or a transmitter with 2 cells, one mounted at the top and one at the bottom. The top transmitter reads the top pressure. The bottom transmitter reads the top pressure plus the pressure from the level. The top pressure is subtracted from the bottom pressure and the result is the level reading. A second solution is to use a differential pressure transmitter where the high side pressure input is connected to the bottom of the tank and the low pressure input of the transmitter is connected to the top of the tank. The transmitter will read the difference, which is the level reading. The capillary connected to the top of the tank is called a dry leg. There is no condensate on the transmitter input. This solution will only work if the gas at the top won't condense in the capillary and allow fluid to develop in the compensating leg. If there is a risk of condensation occurring, then a wet leg is used. The capillary tube on the low input is filled with the liquid that results in a pressure of the gas at the top, plus the pressure from a full tank. The input connected at the bottom of the tank will be the top pressure plus the actual level in the tank. The result is that the output will be the level minus the full value. Bubble level measurement system. A pressure transmitter is connected to the pressure input of the tube. If there is no opposition to the flow, then there is a low pressure read on the transmitter, which is the pressure drop caused by the opposition to flow of air through the pipe. The level in the tank increases so that the pressure at the tube outlet has to build up to overcome the pressure caused by the level. The transmitter pressure will indicate the level pressure. A constant volumetric airflow rate regulator is used to maintain a constant flow rate from tank empty to tank full, low pressure to high pressure.